Hi everyone from my class and Mr. Wong's class. Let's go through these practice problems for Unit 4, Lesson 4 together on Desmos. If you're in Mr. Wong's class, you won't find these questions in the book. Well, this is true for both classes, but I know that Mr. Wong's students are especially used to doing their homework in the book. This one's only online. You got to do this one on desmos.com. So student.desmos.com. All right, so I've already got problem 1 up. Let's take a look at it. Let me get my little drawing tool going. And so we want to know, what is 13% of 200? So one thing I've been telling my students a lot is that where you see the word of, that pretty much always means to multiply. And so in this case, we've got our percent, right? 13 is the percent. And then this is our whole, right? And so we're trying to find a part. And we have this sort of formula that says the percent equals, sorry, I meant to write the part. Let's get rid of that. The part equals the percent times the whole. And so we're going to wind up multiplying. Just like I said, the word of between that 13% and that 200 kind of means you're going to do 13% times 200. And the formula says to do that same thing too. So to find our missing part, we're going to do 0.13 times 200. And you could put this into a calculator, but if you kind of understand how percents work, I think you could do this one without, because I'm thinking about the fact that 0.13 times 100, well, to do that, I would just move that decimal point over 2 spaces, and this becomes 13. And so 0.13 times 200, that ought to just be double. It's supposed to be an equal sign. That should just be double, right? Because instead of times 100, I'm doing times 200. So I'm going to double this 13 to 26. So I think that's our answer here, 26. It says submit and explain. When you explain, you can just kind of talk about the work that we just did together. All right, so next, match each fraction expression to the equivalent percent expression. Okay, so some of these have percents and some have fractions, and we have to match them up. And so I'm going to organize them first. I'm going to put all the percents over here. There's 4 of them, and all my fractions over here. All right, and so this is just like, can you match a percent to a fraction? So I look at 1/4. For me, percents and cents, like 100 cents and a dollar, really go well together, and they're almost like the same thing, because well, there's 100 of both, right? 100%, 100 cents. And so when I see 1/4, I think of which coin do I have to have 4 of in order to make a dollar? It's a quarter, right? And so that's why sometimes people say 1/4 instead of 1/4. They mean sort of the same thing. And so 1/4 is 25 cents. That's the same thing as having 25%. So I'm going to go 1/4 and 25% being the same thing. And so by that same logic, if I have 3/4, otherwise known as 3/4, that's like having 75 cents. That's the same thing as 75%. So I'll match those up. All right, we've got a couple left here. We have 4% and 40%. Well, 4% is way smaller than 40%, right? And so the smaller of these two fractions should match up with the smaller percent. A 1/25 is way smaller than 2/5. So I think the 2/5 should go over here. And that makes sense because 1/5 is the same thing as 20%. 2/5 is the same as 40%. And then here, 4%, that's just a little amount. That's going to be 1/25. And you should notice if you take 4 for the 4%, multiply it by 25 because it's 1/25 of the whole thing, it gets you 100. All right, let's move on to the next one. Match each situation to a diagram. Okay, so I'm going to put the word questions over here on the left and the diagrams over here on the right. Okay, so the character's name in these questions is almost like Mr. Wong, but it's an O. I think it's still pronounced kind of the same. I don't know. Wong, I don't know. I'm just going to say Wong. So Wong runs X miles. Nikisha runs 75% more than that. Okay, so Nikisha ran 75% more or further than Wong. So I got to find one where there's like an X bar and then another bar that's going 75% beyond that, right? And so I look at this A diagram. This blue part represents X, right? That's how far Wong ran. It says he ran X miles. And then it's broken up into 4 chunks. And then there's 3 more of those chunks beyond that to make up what Nikisha ran. And so 3 extra fourths, 3/4, 75% further. I think these got to match up. All right, here it says Wong drinks X ounces of juice and Nikisha drinks 25% less than that. All right, so this time I'm going to look for a diagram with an X. So I'm on this word problem in case you're not sure. So I look for an X that represents like the whole amount of juice that Wong drank. And then there should be a Y bar representing Nikisha that's 25% shorter than that, right? And so my 2 choices are B and C. Just by looking at them, I feel like B has to be the right answer, right? Because it looks like it's 25% shorter, where this one in C, the Y bar looks like it's way shorter. So I look at the X bar here. It's broken up into 4 pieces, and the Y bar is one of those 4 pieces shorter, 1/4, 25%, 25% less than. I think that those got to go together. And so by process of elimination, this one says that Nikisha buys 25% of the almonds that Wong bought. And so her bar should only be like 25% the length of the X bar. And that's what I think we see in number C, or letter C, whatever. All right, moving on. Problem 4 says, select all of the expressions that are equivalent to 5% of 60. Okay, so when I hear that word of, it makes me think of multiplying, right? 5% of 60, I want to do 5% times 60. And so right off the bat, I'm thinking 5%, well, 5%, if I want to turn that into a decimal, I got to be careful. The decimal point is right here. I go 2 spaces, 1, 2, which creates this gap that I have to fill with a 0. And so this becomes 0.05, right? 5% is 0.05. And so the first one that comes to mind for me is 0.05 times 60. That's for sure 5% of 60. So I'm looking for that one. And that's right here. Nope, I almost made a mistake. It's 0.5 instead of 0.05. So nope, that's a trick one. Here we go, 0.05 times 60. And then the next thing I notice is that in my decimal 0.05, the 5 is in the hundredth spot. Right, 5%, 500ths, it means the same thing. And so I've got a fraction here, 500ths times 60, it's the same thing. Now I see 1/5 times 60. 1/5 and 5% are not the same. That's not the way it works. 5% is the same as, 5%, let me put a percent symbol on there, is the same as 5 hundredths. Percents and hundredths are the same thing. And so 5 hundredths and 1/5, those aren't the same. I'm not going to go with that. But I do see this 1/20th down here. Does 5 100ths equal 1/20th? Are they equivalent fractions? I think they are. If you divide the top of this fraction by 5 and divide the bottom of this fraction by 5, you would get 1/20th. So this says 1/20th times 60. That's the same thing as 5% times 60, 0.05 times 60. All right, let's look at the next one. Oh. Okay, it says a new soft drink has 20% less sugar than before. The drink has 50 grams of sugar originally. How much sugar does it have now? So there's two different ways you could approach this problem, right? You could figure out what 20% of 50 is and then subtract it out. Or you could think, okay, if 20% of the sugar is gone, that means 80% of the sugar remains, right? Because you've got, like, the original amount is 100%. That's like your whole. So you start with 100% of the original amount of sugar, but you're reducing it by 20% sugar. And so you're left with 80% of the original amount. This is the way I like to do these questions. So I'm just going to do 80% of 50, and that's 0.80, or just 0.8 times 50. And, well, I know that 8 times 5 is 40, right? And so thinking about the way the decimals are going to work, you can just punch this into a calculator, but in my brain, I'm having a hard time like explaining it, but I can tell that the answer to this is 40. So 40 grams of sugar. I keep double clicking. All right, problem 2.1. Use the sketch tool to draw a diagram that represents the following situation. The amount of flour that the bakery used this month was a 40% increase compared to last month. Okay, so I'm going to do it just like I'm not a very good artist. I'm not going to try to draw bags of flour or some crazy thing. I'm going to do it like these ones over here, where you had one bar that sort of represented the original, and then either a longer or shorter bar underneath that represented like if it was more or less now. I'm just going to do it like that. And so let's start by just making like a bar that represents the original amount of what we had. And I'm going to leave some extra space because I know that the other bar I'm going to draw is going to be 40% more, right? So I'm going to save some extra space. Well, 40% is the same as 40 over 100, which if I divide that by 4, right, this is 40%. If I divide that by 10 on top and bottom, I'll get 4 out of 10, and I can simplify that even further to 2/5, right? When you're trying to draw these diagrams or understand these diagrams, being able to take percents and put them into fractions and vice versa is really important, because the way we divide this bar out into parts is going to be the way that this diagram makes sense. And so I see that 40% is the same as 2/5, and so my other bar that I draw is going to have to be 2/5 longer. And the only way to really represent that like intelligently is to break the bar up into fifths. And so I'm going to show that like this original is 5/5. So 1, 2, 3, 4, 5. This one's a little bit bigger than the rest, but whatever, close enough, right? And so I'm going to label this as last month. And then this month is supposed to be a 40% increase over that. So I'm going to draw another bar that is the same length, and that's going to be 5/5, right? One whole, 1, 2, 3, 4. But then it needs an additional 40%, which is the same as 2 more fifths. So I'm going to just make it this much longer and have it be 2 more boxes, 2/5, and that will be this month. There we go. And I think we got to do another one of these on the next page, but it's going to be a reduction rather than a like a percent decrease. This one we would consider a percent increase. The other one will be a percent decrease. Why is it always double click? I swear I'm not doing that. All right, it says, use the sketch tool to draw a diagram that represents the following situation. The amount of milk that the bakery used this month was a 75% decrease compared to the last month. That's a lot. Like they used a lot less milk. I wonder what happened. They go out of business or something? All right, so the first thing we should do is figure out this as a fraction, where we need to be able to divide our bars into like proper fractions in order to make our diagram make sense. So let's turn 75% into a fraction. Well, if you were listening to me earlier about that whole like percents and cents and dollars thing, you might already know that this is going to turn out to 3/4 because 75 cents is like having 3/4. That's 3/4. But the way you would do it more properly is write it as 75 100ths and then simplify from there. And I don't know, I might start by dividing the top and bottom by 5, and that would get me what, 15 20ths. And then I see that I can do 5 again, right? I can divide by top and bottom by 5 one more time, and there we go. We got 3/4. And so our new bar that's going to represent this month's milk usage needs to be 3/4 shorter than whatever original bar I make. So I better make my original bar into like fourths so the diagram makes sense. So first I'm going to just draw one bar that represents the whole, and I'll put it into 4 pieces, 1, 2, 3, 4, and I will call this last month's usage. And then this month is 3/4 less, or 75% less. And so it needs to not have 3 of these chunks. In other words, it's only gonna have 1 chunk. There we go, big reduction, big decrease. All right, and I guess we'll just move on to the last question, then we're done. What do we got? Okay, Gabriel created a double number line. Fill in the value at each unlabeled tick mark. Okay, so what we have here is like actual numeric values on the top number line, and then the percents that they represent on the bottom number line. So in this case, 75 is our whole because it's like aligned with 100%. And so if we look at the number line down at the bottom, we go all the way from 100% to 10% because my first goal is I want to try to fill in this box. Well, okay, 75, what is 10% of 75, right? Because whatever's in this box should be 10% because it's lined up with 10%. Well, to go from 100%, oops, that was supposed to be 100. I'm gonna do this. 100% divided by 10 equals 10%. All right, that's what I'm doing down here. I'm dividing by 10 along this line. And so just to make sure that the same thing happens on the upper number line, I just do the same thing here. I should take this 75 and I should divide it by 10. This is sort of like proportional relationship stuff here. And so 75 divided by 10 equals 7.5. So this should be a 7.5 in this box. And then here, this box is supposed to be aligned with 60, right? And so there's other ways you could do this one, but the way that pops into my head right off the bat is like, okay, I'm trying to find a percent, right? That I know that what goes in this box should be a percent because everything on this number line is a percent. And what I have is a part right here, this 60, and I have a whole, this 75. And so let me just do it this way. Percent equals part divided by whole. That's going to be 60 divided by 75. I could punch into a calculator, but I also notice that this fraction can simplify a lot. It might make my life easier. Let's see here. Let me divide top and bottom by 5. And I'm going to get 12 over 15. And then I see that 3 can go into both of those numbers. And so 12 divided by 3 is 4. 15 divided by 3 is 5. So 4/5. Okay. But what is that as a percent? I was supposed to find a percent, right? It's not 4/5 percent. I gotta convert this 4/5 into a percent. You could do it by just hitting a calculator. 4 divided by 5, you would get 0.8. The way I'd rather do it is if I can get the denominator to be 100, then whatever's on top is the percent. And so I know that 5 times 20 is 100. And so I'll multiply the top by 20 as well. I get 80 over 100. So it's 80%. So what we're saying here is 60 is 80% of 75. All right, I think that's it. And I'll see you in class. See you next time.